It's space weather. Sunspot 2733 still producing flares. Here at the end of this video you see a C-class. Just happened in the last hour or two. Check it out. Looks like there's some ejecta created also. Here are the magnetic lines. And let's look at the LASCO C2, see if there's any coronal mass ejections. Looks like there is a little bit of plasma coming out of the western limb there, as well as the eastern limb. Several pulses. Move this up a little bit so you can see the date stamps. Let that play through. Look at the rest of the data here, spaceweathernews.com. There you see that X-ray flare. It was actually quite long lasting and had some little B-class spikes at the end of it. So Sunspot 2733, we're going to keep watching it after it's out of sight, by the way. We see this phi angle here. Some coronal hole, sun-to-earth magnetic connections going on. And as a result, the risk for a 7+ magnitude earthquake remains in effect. You see the solar wind is all the way down to about, we got different figures here. We'll say it's at about 5 protons per cubic centimeter. Solar wind is down all the way down to about 300 kilometers per second. Magnetometer is looking very smooth, and the KP is back to 0, so cosmic ray human health alert in effect. Here's your cygnus forecast, and that's through February 6th. Here's your electron flux, very flat, although at a nominal to high level. No charging hazards. There's your F2 ionosphere layer, looking slightly anomalous in that it's fairly charged here and fairly discharged here, but less so than we've seen previous days. Aurora forecasts are weak. Let's head to spaceweather.com, talk about the 10.7 centimeter radial flux for a minute. Now, 10.7 centimeter radial flux has dropped back down to 73. Let's just look where this plays in predictions. Yesterday it was up to 74, and we see the predictions are for it to drop below 60 down here, and we ain't seeing that. So the actual data is more like this. Just making a note of that. Slightly higher 10.7 centimeter radial flux than predicted. Moving on. Next, we'll head to the Space Weather Enthusiast dashboard. Something all of our viewers must have saved in their favorites. Otherwise, why'd you be watching the channel? We're going to see this C-class flare. So let's zoom in on the sunspot. Let that play through one more time. There it is. Kapow. Little bit of X-rays. Next, let's look at the gong 2. By the way, this is the top view ecliptic plane field plot. Please note the data is 2 hours and 6 minutes old. Alright, so We're going to see a little bit of magnetometer fluctuation here. Let me just advance this to the last frame. The magnetometer fluctuation, let's see. Okay, so this region here didn't show us very much on the magnetometer. It's probably going to be smooth sailing across this region and this region. Although the last of the three is now the most likely to produce any significant spikes in the magnetometer. Keep in mind, this is subject to change instantaneously and with no warning. And also the effects happen instantaneously, faster than the speed of light. Next, how about some magnetosphere movies? Thanks to the University of Michigan, here's a velocity, which you can see is quite low. And that light orange is reflecting what we see in the solar wind data, right around 300 kilometers per second. Next, the density, which is fairly steady here. Looking right around just nominal levels. No real waves of low density solar wind coming in. I'll let that play through. And regarding the pressure, you're going to see a very low pressure. Although not as low as some days we've looked at in the past. We want to cover it each day in case there's some variable that we're missing when trying to tie a lot of variables together. Next, we've got data about the geospace ground perturbations, of which there are not many, and the ones that we do see are quite weak. Not a lot of magnetic spillover there. Here it is from the poles. Nothing much to see here, folks, but we let it play through anyway. Let's go back about 12 hours for earthquakes. So we've got a 4.5 in El Salvador. 4.2 up there near Fiji and Tonga. .1 up on the plate boundary east of the Philippines there. The Mariana Islands. 5.5 in Peru. I think that might be the biggest one we've had in the past 12 hours. 4.6 at Fiji at 472 kilometers depth. 5.4 in Mexico. 4.9 in Papua New Guinea. 4.4 in the Northern Mariana Islands. 4.6 in Tonga at 252 kilometers depth. 4.9 at a deep depth at the Philippines. 2.8 at 150 kilometers depth at Puerto Rico. A lot of deep quakes going on right now, people. 5.3 at Taiwan. 5.3 at Tonga. Well, without looking at any other data, I gotta say, Indonesia, Papua New Guinea, New Zealand, Tonga, Fiji, I still say remains on alert for a 7+. And the candidate number 2 would be Western South America. Also, let me take a moment to thank people who donate. We have had people asking us to provide an address so they can send us things. We don't have a P.O. box, so we're not going to divulge our location. So we do have a PayPal and a Patreon account. So if you feel like donating, we do appreciate that. Now let's look at volcanoes. Alright, so Shivaluch. So we got a little volcanic uptick here. Shivaluch producing a 21,000 foot ash plume. Popocatépetl looks like it's dissipated. Fuego, continuous volcanic ash emissions. Reventador with a 14,000 foot ash plume. Sabancaya, sporadic emissions. And Planchon Peteroa, 15,000 foot ash plume. And it looks like Stromboli has decreased in activity. That's a good thing. Next, we got an article from SciTech Daily. The headline reads, "New results show dark energy may vary over time." They're going to come up with every possible way to figure out why the universe is made 97% out of stuff that's not existent. Non-existent dark matter. We'll leave links to the article. I don't think it advances anything except a fundamental misunderstanding of the universe. Here's one on Universe Today, looking at a supernova shockwave and what's happening when it hits interstellar space. Now that is interesting. It would be nice if they could understand that the mechanisms are electromagnetic in nature and not gravitational, but at least they're studying it. Supernova SN197A, a very famous supernova. Those of you who are into space, you've probably seen photographs of this thing before. We'll leave links to the article. They're studying what's going on in these areas. Here's a phys.org article. Active galaxies point to new physics of cosmic expansion. Dark matter. Dark matter. They think everything's comprised of dark matter. Here's another phys.org article. Ancient crystals offer evidence of the start of Earth's core solidifying. Now, sounds like it might be a step in the right direction. Somebody found some crystals in eastern Canada, and there are some characteristics of the crystals suggesting that they're really old. And the solidification began as far back as 2.5 billion years ago. Not so sure on that, but it is some interesting science. And it does involve the Earth's magnetic field. So have yourself a read over at phys.org, if you see fit. Lastly, we got a video here by Robitaille, once again, talking at EU 2014, all about evidence. He's talking about the cosmic microwave background and the signal-to-noise ratio, and how the cosmic microwave background isn't science. It's considered evidence of the Big Bang, which people were looking for real hard, to the point where they decided to use a signal-to-noise ratio of 2 to 1. Take it away, Dr. Robitaille. What is going on with that?
So people see, they see these images. Oh my God, this is a real image. We've imaged the universe. That's because they don't really understand what is an image. So this is this famous image after the removal of the galaxy. Now here's the noise that they plot in their paper. So they give us a noise of plus or minus 100 microkelvin at this resolution. And we know that their images, were at plus or minus 200 at this resolution. These, I can't remember, I don't think these are identical resolutions. But you can gather from their data, if you look at it carefully, they have signal to noise of about 2 to 1 relative to the noise of their instrument. Now, I just wanted to show you some MR images of things, or different images. We won't say they're all MR.
So here's a super interesting demonstration here, looking at 2-to-1 signal-to-noise ratio images. Can you tell what these are? I'll bet you can't.
2.1 signal-to-noise, 2-to-1 signal-to-noise image. This is an actual image, probably of my head. This one is of importance to us here. This is an image of the moon. And this one, no one will guess, it's the image of my right hand. So when you have no signal to noise, guess what? You don't have an image, unless it's reproducible. And their image is not reproducible. So
the point is, the microwave background images are not reproducible, which means they're not science. Let's look at a few more images of the sun. Check out this most recent activity here from Sunspot 2733. Check it out. How about a little solar activity, folks? And 94 angstroms. Takes 5 times as many pictures as the other cameras. Let that play through twice. There's your flares. You'll see the C-class flare right at the end of the video. Thanks for watching, everybody. Remember, when you're continuing to watch a sunspot, despite it leaving the Earth-facing solar disk, don't drink. And if you drink, watch a sunspot after leaving the Earth-facing solar disk anyway. And don't drive.